Grüß, willkommen in einem Fragens video. Welcome to another exciting and dynamic video, in this case part 4 of my Information Technology Thoughts series. In this video, I'll be providing an easy method for someone at home to create, compile and execute a C program without purchasing any software in order to do so. Almost my entire experience with creating and compiling C programs was on my company's system, starting with the trusty old System 5 Tower system from NCR, then Prime, Wang, Data General, Pyramid and so on. Most of the systems I worked on were System 5, but at Sun I used a BSD-based system. However, few people have access to a business or enterprise computer of this nature. While I have to admit it is possible to create, compile and run C code on a Windows system, for now I want to only focus on Unix or specifically Linux systems. You can do this on a Windows environment, but Windows is not really optimized for the writing of this type of code. First, let's deal with the hardware. Most people probably have old PCs which are no longer powerful enough to run the latest bloatware from Microsoft, unless they are lucky enough to run a copy of Windows with all the bloatware removed. One way of getting some use out of these older systems is to download a Linux distro and installing it on the system. In my case, I'm using an old Shiba M11 Tectra, which I suspect I got around about 2010, if not earlier. Now let's look at the Linux. There are many different versions of Linux. I have installed and used a number of different distros, but currently prefer Zorin. These setups could work if you decide you wish to use another distro. That is, this video could work with other distros, such as Mint or the classic Ubuntu, but I've selected Zorin. The reason why I selected Zorin is it has a good look and feel, is easy to install and configure, and has a great library of free software. Once Microsoft EOL's Windows 10, I'll probably move most of my computing onto that OS. If you go to the Zorin download site, which I'll include in the notes, but if YouTube stops this, then simply search for Zorin download, and you can see the spelling in the screen here, and you should end up with this site. For now, let's try the free 16.2 version, but if you like, you could consider the 16.2 Pro and give them some much needed money to support their efforts, which I think is very much a good money spent well. When you click the correct button, the OS should auto-download. This may take a reasonable period of time, so you may need to wait. The file is in the form of an ISO file, which means if you place it on a bootable USB stick, you can boot off it. Once the file is downloaded, select your Next Step button. You can actually click this button before the file is fully downloaded and basically download the next steps while you're waiting for the download, but I'll leave that entirely up to you. Once you click the next step, it'll give you a list of what you need. Basically, what you need is an old computer, which we've already discussed, and a 4GB USB flash drive or USB stick. If you're downloading the Pro, you need a 16GB USB flash drive or USB stick. Let's for now put the external drive to one side. It needs to be noted you will need a network attached at some point, but not until you've installed your computer. I typically install it with a network attached from the word go, but you can decide to do it in a two-stage process, up to you. The next step that it lists is downloading a Zorin ISO file. Well, we've already done that, so let's not worry about it, but if it doesn't work, you can click on this and work out how you can overcome any problems that you may have. I had no problems, I've downloaded it a few times, so I would assume that you should have no problems as well. If your old computer has any usable operating system and files on it, then you may wish to back up any of the data on it. In my case, I had a laptop with no operating system, so it was not an issue. If you do not like Zorin, you can always do, or if you're a bit unsure about wiping your old computer, you can also do a boot off the USB stick. And even if you do wipe out your original OS and you don't like Zorin, you can always go back and reinstall Windows. And if you're doing this on an old computer, it's probably a good idea to try and get a little bit more performance out of your system because you've just newly installed the OS. The next step is you need to create a bootable USB install drive. In my case, I used a different tool to do this, but Ballen Etcher is as good as any other tool to use. Just simply follow these reasonably simple instructions to create your bootable USB drive. If you're worried about getting some virus from the internet, use the PC, that you will soon wipe clean to run Balin Etcher. That is, if you download the flash drive software on the PC that you're going to be wiping anyway, then it doesn't matter what virus is on it. But anyway, I've had no problems at all with viruses or any problems of that nature downloading this software. Once we execute a Balin Etcher, don't know if that's how you pronounce it, but anyway, let's call it Etcher, you then select Flash from a file, as you can see here on the screen. Once you've done this, you select the target. Make sure you select the correct target. Once all that is done, you finally hit the last button, Flash button, to create the bootable flash drive. Now, if for any reasons you do have any issues with creating your bootable USB drive, you can try a different software option. In my case, I normally use Rufus, but that's purely for historical reasons. I also use Popsicle for Linux again, but again, that's historical. Now we come to the first tricky bit, getting the computer to boot off the flash drive. In my case, my Toshiba laptop uses some strange key combinations to force the boot off the flash card to occur. If you have any issues with this instruction, you'll need to download the manual for your computer to find out how to boot off another device on your computer. If you've hopefully worked out the correct key combinations to get to the boot menu, you can now select the boot device and boot off your flash drive. Once you're finally in this screen, you can select the boot option that you wish to do at this point in time. In my case, I went for the option 1, but if your computer is more modern and has an NVIDIA graphics card, you can try the NVIDIA option. Option 1 will work and get you a system to run code on it, and often the correct graphics drivers will download later, but that's entirely up to you. This step here comes up this is only really an issue if your USB drive is old. Make sure that the USB stick that you're using does not have any problems with it or hardware problems with it. One other option you do have is you can run Zorin off the USB stick, but I simply installed it on my computer as it had no operating system on it at all, and I was never going to run anything but Linux on my laptop anyway. At some point you will need an internet connection. I would connect the computer up to the internet from the start, but if you have no connection up until this point, then do so now. I would also use a cable connection. While Wi-Fi may work, the drivers may not yet be installed on your computer. A cable connection will obviously always work. When you get in this screen, you have 3 options. In my case, I selected the second option and installed it on my laptop. If you have multiple drives or SSDs, then option 3 will be required. Once all that's completed, you should be good to go. I'd keep your USB flash drive somewhere safe just in case you want to reinstall it again. Once you reboot your system and start creating logins and such, the system will probably go crazy and download lots and lots and lots of updates. This may take a while. You may also wish to install other software from the software site. I'll leave that up to you to work on. For now, the next step is to install a compiler on your system. Incidentally, I would probably not do anything using the root login. I would create your own user ID and do all your programming from that. But of course, give it admin rights. If you log into a terminal window and type cc, the system will give you about 4 different ccompile options you can install. I decided to use GNU-C, so execute the install command provided and you'll end up with a GCC or GNU-CC on your system, ready to use. You will need to use the install command. Make sure you have admin rights or your login is an administrator in order to do this. Incidentally, the way you find your terminal window is in the bottom left corner. There's a menu, go in there and eventually you'll find the terminal window button that you can hit and you'll get what you see in front of you now. While we're downloading lots of stuff, we should possibly consider downloading some documentation to help you in your programming efforts. The most important book that you need to get is the C Programming Language by Koenig and Ritchie. You can find it free on the internet, at least I did. I'm not going to provide a URL because I'm uncertain what the copyright restrictions are, but you should be able to find it quite easily. Now, another useful, but I must admit not essential manual to learn C is the System 5 Programmer's Reference Manual, which is also available free on the internet. Once again, do a search, you'll find it. I'm not providing a URL just in case there's some copyright issues. I'm certain you can find lots of other books to assist you at a very low price, or actually for free, most likely. One note, it's probably wise to make sure you download a digital copy, a digital PDF, so you can do searches within it. Let's start with a simple program. Using VI, create the file called test.c. Now, if you're unfamiliar with VI, there's probably a text editor on the system that you can use to create your program. Or alternatively, I will be creating a video to give you a quick rundown on how to use VI. I use VI because it is available on every version of Unix known to mankind, and I know it backwards. But I must admit, if people are not familiar with the VI editor, they may freak out at the way it works. But anyway, that's my comment about VI. Now, when we look at the code here, which incidentally is a piece of code in the Carnegie and Ritchie manual, or the first program, which prints a hello world, the first line simply includes what's called the standard I/O libraries. The command requires to get some form of output resides in this library, which is why we need to include it. The second line represents the beginning of the first piece of code, which is executed, called main, and it returns an integer, which we'll talk about briefly later. The third line is just a comment, it has no impact, it's just there to tell you what's happening. The fourth line is using the printf subroutine, which will pump something out on your screen. In this case, we are outputting a single string, a single string called hello world. The fifth line is not really required, but should be added to comply with the way C programmers work. I think you'll find if you don't put it in there, it may come up with an error message. Your program should return something. In this case, it will always return a 0, which theoretically can be used by other programs. In this case, it wouldn't be used by any other program, but nonetheless, that's the convention. And of course, at the very end, we got the curly brackets, which indicates this is the end of this bit of code. Now, in order to compile it, we need to use the command gcc space test.c space -o space, or lowercase o, remember that, space test. And that will compile your piece of code. Now, you don't have to have the -o test. If you just go gcc test.c, the program will come out as a.out or something of that nature. I tend to like to make sure that whatever I'm compiling, the name does match the source. But again, it's up to you. Incidentally, I would also probably create a subdirectory called programs to do all your programs in, as you can see here. If we use the ls command, which is the list command with no options whatsoever, we should now see the file test. If you go ls-l, you can get a little bit more detail about individual programs, but you can see now the test file in sort of a green and test.c, which is your source. In order to execute it, we would use, I know this sounds rather odd, but a ./test. So it knows to execute the file called test in the current directory. Otherwise, it goes all over the place looking for an executable file, and there may be something else out there called test. But anyway, if we type it as you can see here, hey presto, we get a hello world. Now, you'll probably notice that the hello world, there's no new line at the end of it, so you've got your cursor prompt appearing immediately afterwards. Now, if you want a new line at the end of the string, hello world, you need to add it in the code using the /n, which means new line, string, as you can see on the screen here now. We then recompile the program, and now we get a new line after the hello world. Hey presto, we've created our first bit of code. Now, if you want a bit of code where you enter a character and then have it displayed back to you, there's lots of different ways of doing it, but one way you can do it is using the scanf subroutine or function. In this case, we're taking a character described as the %c, which means character, and we'll associate it to a pointer called input. And we know it's a pointer because there's a ampersand in front of the word input. When we display the contents of the pointer, we get our character. Although when we look at the printf, you will notice that we now have to stipulate %C to indicate that we're displaying a character. That's the format that we're displaying, where the input pointer is pointing to. I know this all sounds rather confusing, but it's the way that C works. Once you get your head around the way that it stores information in code, you'll basically think it's second nature, and all programming languages should use the same system. Possibly not, but anyway, that's what I think anyway. Once we've compiled this wonderful new piece of code and execute it, we get a chance to enter a character and have it displayed back at you, as you can see here. Let's drill down in a little bit more detail to the printf subroutine or function. Printf is called a subroutine or sometimes function. I'm not quite sure why the two namings. There may be some logic behind it. But anyway, I just do what I just accept what's there. The full name of it is printf in brackets 3s. The 3s means standard I/O library routines, or it means this is where it resides. To access this subroutine, you need to include the standard I/O libraries, which is why we did include it in our bit of code. If we look at this printf usage, we can see it's displaying the contents of 5 pointers. Weekday, month, both of them are strings, day, hour and minute. The last 3 are standard variables that are kept in the system. To make sure the values are correctly displayed, we need to define its format. So the %S means that it's a string of characters with some sort of end of string character at the end of it to indicate the end of it. The %I means that it's an integer. %D is a signed decimal, etc. The point is you need to place the pointers that you can see on the right, the names like weekday, month, day, hour, minute, in the same order as the output format that you're defining, which you can see as %S, %S, %I, %D, and %.2D. Incidentally, these web pages, or these pages that you see here, come from the System 5 Programmer's Reference Manual, and it's the reason why I like to always have a copy of this on my system, normally in a PDF format, because that seems to be the way of the future. Anyway, unfortunately, I lost all my manuals many years ago on one of my moves between probably Japan and China. I'm not quite sure where it is, so it's probably at the bottom of the China Sea somewhere in a container, which is really sad. But anyway, we've got electronic versions, and that's what I would advise you to have. So let's look at the next command, which is scanf3s. We can also see that this is also in the standard I/O library. Now let's move at a completely different program, which is the second program in the Carnegie and Ritchie manual. And this shows you how to do a bit of logic looping within a bit of code. Now in this case, the program is a temperature conversion program. Very simple one, but nonetheless an interesting one. When we execute it, the result is as follows, with the Fahrenheit values followed by the Celsius values. Let's go back to the code to understand how this works. What we're showing here is an example of some sort of loop. The while condition is true. While the condition is true, it keeps on looping round and round and round. In this case, once the FAHR value exceeds the value set by the field upper, it stops. If you didn't have that there, it would go forever, and you'd have to, probably kill the process in some way, shape, or form. So one of the wonderful idiosyncrasies of coding is it's very easy to completely suck up all the CPU capacity of your system. So be careful. So you are now able to write, compile, and run C programs. My advice is to download this book and go through the exercises and examples, and you'll become a C programming expert. If you want more details about the subroutines or functions, you can find most of them in this book, which can also be downloaded for free. And so we come to the end of my part form of my video on Information Technology Thought Series, in this case providing a simple method of writing, compiling and running C programs in the comfort of your own home. Alle guten Dingen, kommen zu einem Ende.